Hello and welcome. Is everyone sitting comfortably? Haven't got a copy of the agenda in front of them? I want to formally welcome you to the AGM. I'm Jonah Grunsell, I'm chair of the board. We've got a hopefully very interesting kind of agenda for today to try and share with you some of the progress we've made in achieving our aims and also to hear from some of the people that we've been working with. The agenda we might need to make a little bit fluid because some of our speakers have had some travel issues. So we will, if you can possibly bear with us, so if it doesn't quite fit to the agenda that you've got in front of you, then that is the reason. And if you see people hurriedly speeding in, sweating away, I'm sure you'll make them feel as welcome as possible. And indeed, Phil, our first speaker, has literally just arrived, and you can kind of see from the beads of sweat on his head. So I know that you'll make him feel very welcome and understand that he feels slightly flustered. So that's good. Other thing to note, and just to reassure you, you can see Sonia has her laptop open. That doesn't mean she's not paying attention. It's very important that she monitors social media, and also she's paying a very close eye to the Big Give, which is going very well, but I won't steal her thunder, and we'll give you an update about where we are with that critical. So she's pointing and smiling, so it's definitely a good thing. And we'll give you an update later to share with you that exciting news. I think that's pretty much all from me for now. I'm going to hand you over to Phil.
Thank you, Jonah. Good morning, everybody. I have literally just run through the door about less than 10 minutes ago due to travel issues, so I'm a little bit flustered and tired, but that's the way it goes. I'm here now, so it's nice to be standing here today. I'm standing here today as hopefully a new trustee of Action for ME. That should be confirmed later today. So I'd just like to say hello, and this is who I am for those who haven't met me so far. And I'm going to speak a little bit about my journey to this point, and then my work with the Patient Advisory Group for the CMRC, which is the UK Chronic Fatigue Syndrome ME Research Collaborative. So first of all, those who don't know me, a little bit about me. 21 years ago, I was a fully fledged person of the world with a job, with hobbies, interests and a social life, doing everything in the fast lane. And I was struck down by a virus, and within 6 weeks I was completely bedridden with what the doctor said was post-viral fatigue syndrome. And this turned into a 7 to 8 year battle for the fluctuating condition we call ME. It took down everything I had, my job, my interests, my sport, everything that I was doing really just collapsed. And I was on benefits for 6 years. I'm in the remarkable position that I've made a full recovery, which I'll explain how that happened in a moment. But I actually managed to get back to the world of full-time work and everything else that goes with it. And then about 6 years ago, I noticed that there was a lot in the press about treatments for ME. And even though I wasn't really thinking about ME anymore, I was aware that I didn't agree with these treatments that were being proposed as guidelines for treatment, because this is the opposite of the advice I'd been given. So I started to take a keen interest in the world of ME again, and that brought me into contact with the likes of Action for ME, who are quite near to where I live in Bristol. At this point, I'd just like to say that when I was recovering from my illness, I volunteered with a charity in Bristol called Westcare UK, who are now no longer with us. But the advice they gave me was early diagnosis and early management, and don't try and push through and beat it with positive thoughts and we can get through this, keep battling on. They gave me the opposite advice to that. So I was told to go away and rest. And this is what I did. I didn't like it because I found it very boring, but I went up and rested for at least half my time when I felt well. And I believe that's the cornerstone to my recovery. So those people who are being told they need to do more or to stop dwelling on their symptoms and to push through, I don't agree with that at all. So that's kind of where I've come from. And in recent years, I've been a bit dismayed at the lack of biomedical progress in 21 years. I literally read something a few months ago which said that a drug called amitriptyline was being trialled. It was being trialled when I got ill, because I remember reading about it in 1998. So this has been very little progress in 21 years certainly from a guidelines point of view, there's been zero progress, and from biomedical research to actually proper targeted treatments which have been proved to work, almost no progress. So that makes me very motivated to change this state of affairs, because I don't think it's right. So that's where I am today. Now, I first came into contact with the likes of Sonia and Claire 2 years ago when the CMRC wished to amalgamates with them a patient advisory group, which is a group of sufferers, carers, recoveries who are going to help guide their research priorities into the future, which obviously they're still doing. I'm hoping that one of their speakers will arrive. Maybe he's having a bad journey too.
Just arrived.
Oh, and here he is. Hi, Neil. So 2 years ago, I became a member of the patient advisory group to the CMRC, I was very pleased to be selected. It was a great honour, and I've been in that group for 2 years now. And what we do is we are actually full board members of the CMRC with an equal voice as the scientists on that group. And we are encouraged at all stages to give our voice to their meetings and their decision-making processes. And we act as it's between 8 and 15 of us. We're actually recruiting at the moment for some fresh faces to join us. But we are very much in touch with the ME world. Many of the people in the group are sufferers themselves, and they are often homebound, so they keep on in touch with the developments in the ME world on social media and the like. And we are therefore in a fairly good position to inform the scientists of the CMRC and the leadership of the CMRC where we think we need to go with this illness at the moment. And I'm glad to say that the chair of the CMRC is very, very happy to have us on board, and he's always asking us for questions and answers to help guide him in his research priorities, which is what we're working on at the moment. If you've been to the CMRC conferences or seen them on YouTube, we've spoken at both of them so far to make sure that everyone understands the patient voice is out there and it's being heard. We do have a bias. We feel, and I feel personally, that enough research funding and time has been given to behavioural interventions for this condition. Before I got involved again, there was a lot of money invested in behavioural treatments and trials, and I think it's had its day, personally, and I and the people with me on the patient group believe very strongly that this is the time to really fund solid biomedical research into the causes and effects of this illness. And I say this illness, is it one illness? I mean, I believe it is many illnesses, and herein I think lies the problem. It's a collection of illnesses. It's a syndrome which is described, and I personally believe that within that there may be discrete underlying conditions. And this makes the search for a single biomarker extremely difficult, and I think it might be almost hopeless to get one unique biomarker for everybody with chronic fatigue syndrome stroke ME or ME stroke chronic fatigue syndrome or anything like that. So it's a very, very difficult task. It's not one which is easy at all. And it does seem to be a lot easier for doctors to say, oh, maybe have you tried doing some cognitive behaviour therapy? Have you tried graded activity? I can put you in a referral. I don't know how much longer I've got, but I keep every week I see something which shocks me in the world of ME, which is why I'm motivated here to make a difference. And last week, the prize went to a woman on Twitter who was referred, finally, to an ME CFS specialist. So this is a UK specialist. I don't know who his or her name is. I assume it's a middle-aged male doctor. So she's had ME for many years. It's really affected her life. She's married. But this doctor's got it all worked out. And it's not a slide, so I'm just going to have to wave it at you. You can come to me afterwards. He drew a diagram of what's keeping her in a fatigue cycle. Over-exercising, under-exercising, undersleeping, followed by oversleeping, being unfit and then getting fed up, frustrated and can't do things properly, alcohol, other illnesses, question marks, leading to stress and anxiety, leading to fatigue and other symptoms. And his final suggestion was, why don't you have a date night with your husband? So this is a UK specialist on CFS-ME, suggesting that a woman with a desperately debilitating neuroimmune condition has date nights with her husband and she might feel a little bit better. So that isn't good enough. So why action for ME? Because we need action in the world of ME. We need it very, very much. And we have to try and make a change to the way this illness is A, perceived, B, treated, and C, research going forwards into the future. Last summer there was a lot of I was actually travelling in the summer, and I was on an email ban. I didn't want to read any emails, but I did see a statement put out by Action for ME on their position around behavioural treatments and research. And at that moment, I knew I'd made the right decision in deciding to apply to become a trustee, because I agreed with it 100%. We need biomedical answers at a cellular level for this illness. And in my dual role with the patient advisory group to the CMRC, I really want to see that happen in the future, and that's why I'm standing here today, and I'll be here all day to see what goes on. So thank you very much. That's me. I'm Phil Murray, and nice to meet you all. And if you want to see this diagram, you can collar me later.
I'd like a copy.
Would you? Okay.
Thank you very much, Phil. Now I'd like to welcome Neil, who'll give us a bit of an update on the research side, and he's going to try and leave some time for some questions after his presentation as well.
Okay. So, is there a laser on there as well? Let's have a look. That is not the one to press. So, okay, got it. Oh, you've got it. Okay. All right, good morning. Well, look, I mean, thank you very, very much for the invitation to talk today. I mean, I think maybe there's a few people in the audience who may have heard me speak before at the conference in Bristol. But, you know, as with all of these talks, it's good to give a disclaimer at the beginning of a talk. And I want to give you my disclaimer now, and that is I'm a UK psychiatrist. Okay, and I have to do this, especially when I talk abroad, because many UK psychiatrists have got themselves rather a bad name in this field. But what I want to do over the next half an hour is to give you my perspective of ME/CFS and how inflammation plays a role in modifying cognition, how it can modify behavior, and get down to some of the nitty-gritty neuroscience to try and look at how can what's going on in the body immune system affect our brain? How does it communicate with our brain, and how does it change our behavior? And right at the very end, I want to talk a little bit about a PhD study that's been funded through Action for ME, and if you like, you can see where we're going to be going with that study. The study's already started, we're already recruiting, but we're quite at the beginning stages of that. So this is going to be the structure of the talk then. So I want to talk a little bit, sort of first off, how does inflammation affect behavior? And then move on a little bit to look at some of these mechanisms. How does inflammation or the immune system in the body communicate with the brain? If it's going to change behavior, the immune system has to communicate with our brains. And then how can we study this in human beings, in awake human beings using MRI? And then finally, how can we begin to use what we understand about these processes to try and help us better understand and make progress in ME/CFS? So I'm going to start with the first one then. So this is a super schematic on the left-hand side. This is a cartoon, if you like, of the immune system. So these PRRs are what are called pattern recognition receptors, and they are receptors on innate immune cells that bind to common elements on pathogens. So they're not specific to any one particular type of pathogen. They're specific to broad classes of pathogens, and they are activated incredibly fast, okay? As soon as you get a bacteria or any sort of infection in your body, these things will be activated. They will sense the pathogens, and they will start secreting proteins called cytokines in general that communicate with other immune cells and start coordinating this immune response in the periphery. And the immune response is, I'm sure you're well aware, is extremely complex. And this involves what's called the innate immune system initially, but then it starts using what's called the adaptive immune system. This is B cells and T cells. These are the things that have memory, that can learn, and that can protect you next time you experience that infection. But even though the schematic on the left-hand side has been taken from a paper by this guy Medvedov, who's really one of the leaders in immunology, what they leave out of this is the effect of cytokines on our behavior. And I think, all of us know that the immune system affects our behavior, because you just need to think of the last time you had the flu. I mean, were you the same person when you had the flu? Or did your behavior change? Did you go, did you perhaps engage with friends? Did you get out? Did you do the things that you would normally do? And I think, we all know the answer to that is no. And sort of nobody was really terribly interested in this until about the late 1980s, when this guy Hart suddenly realized that these changes in behavior aren't specific to the infecting agent at all. In fact, they're the same regardless of whatever infection you get. So that could be a viral infection, a bacterial infection. These effects on your behavior are almost all the same. And the way this work was done is largely in rodents with different infections. And then ultimately, they discovered that you just give cytokines and you can recreate all of these what are called sickness behaviors. So it's got nothing to do with the infection, but everything to do with how your body fights off that infection, the communication that your body does through these cytokines. And just looking at some of those sickness symptoms, I think you can immediately see that some of these have got relevance to the field of ME. And certainly a lot of my work is focusing on depression, and I'll talk you through a little bit about how I think there are some similarities, but importantly some differences in how these may be involved in these two conditions. So first off, this is depression then. So the last slide I showed you is just, if you like, a typical healthy response to an infection. It's believed that by slowing us down when we have an infection, by conserving our energy, this helps us fight the infecting agent. So when we have an infection, our temperature goes up, our metabolic rate goes up about 30%, or the immune system, the consumption of energy by the immune system goes up by about 30%. So this is big amounts of energy that are being consumed when you're fighting an infection. And what this graph shows over here is what happens to people who are treated with a cytokine called interferon alpha. This is a very old study now, but this is a treatment that was used for people who have chronic hepatitis C infection, and also for people who had things like malignant melanoma. It was shown that if you could activate the immune system, you can potentially cure or at least slow down the progression of these conditions. But the problem was, when you gave interferon to these people once a week or twice a week or sometimes 3 times a week, they got really rather unwell, and they got extremely depressed. And some of them became really extremely clinically depressed, and the treatment had to be stopped. And you can see that the longer you give this, the more likely you are to become depressed when you're given this interferon alpha, to the point where, if you're given it for 12 weeks, you've got a 50-50 chance of having a major depressive episode or not. So this is a fairly good evidence that if you activate the immune system chronically, you can induce quite profound changes. In this case, this is about depression. Now, of course, I think we're all well aware, probably you even better than me, that ME is a condition that is associated in many people, not everyone, of course, but in many people with an acute infection or a precipitating infection. And this is just some data from 20 years ago, just sort of illustrating that, in this series, about 72% of people who had a diagnosis of ME at that stage had evidence of a precipitating sort of illness. It wasn't quite clear what the infection was, in many of these cases. And this data, I think, is really very interesting, and I think it relates and ties in quite nicely what we've, published yesterday. And this is a study that's come out of Ian Hickey's group in Australia, and he followed up people who had acute infections in Australia, in a little town called Dubbo, and he followed them up for 6 months, up to a year, to find out what happened to them, okay? And he's an infectious diseases doctor, so all of the serum, as soon as someone got an infection, their GP sent the serum to Sydney, he did all of the processing. As soon as he found a positive result, he sent a nurse down to this town called Dubbo and started, following these people around, literally, for 12 months to see what happened. And I think what you can see on this graph is, if you look at the 6-month period, there's about 40 to 45% of people that have persistent chronic fatigue symptoms, and the scale he used here, he defined as caseness for ME. Okay, so in this series of otherwise completely healthy individuals who developed one of these infections, we know they had an infection, we've got serology to prove that, about 40% of them developed, ME symptoms that were severe enough to be classified as ME 6 months afterwards. And again, of course, the question is, can we predict this? Can we predict who's going to develop these symptoms? And this is a slightly messy slide, but I'll just explain it to you. So the red bars are those people that had, if you like, severe fatigue or caseness for ME at 6 months, okay? And the white bars are those people that didn't. So the white bars are the people that got better who didn't have fatigue symptoms, and the red bars are the people that did have severe symptoms. And what you can see is, at the beginning, right at the very beginning, the people who went on to have sort of caseness for ME 6 months later were the ones that had the worst symptoms at the time of the infection. So they had a much, more aggressive behavioural or sickness response to infections. They had worse neurocognitive disturbance, and he also showed that they had a heightened immune response to that acute infection. So it seems if you're somebody who has a heightened immune response and you experience the symptoms more profoundly, you're much more likely to go on and have ME afterwards. And this data is quite interesting. And again, the colour is a bit rubbish here, but it doesn't matter too much, because essentially when he looked at the serum of these people 6 months later and looked at the people who had chronic fatigue or ME caseness versus those that didn't, he could find absolutely nothing in their cytokine profile at 6 months. So even though they were more reactive at the time of the infection, when you looked at them 6 months later when they still had symptoms, the immune system looked completely normal. So this is a bit puzzling, isn't it? I mean, there's something that's causing this, and then it seems to disappear, at least within the blood. So how does the immune system communicate with the brain then? What is it, what are the processes that the immune system can speak to the brain? And this is a little cartoon that's from a guy called Robert Down. So he's a very famous French scientist who's now based in Houston in Texas. And he's shown that, if you like, there are two classes of ways that the immune system can speak to the brain. One of them is what's called a neural pathway. So there are nerves within our body, the autonomic nerves, the parasympathetic and sympathetic system. More than half of the fibers in that autonomic nervous system are in fact sensory. So they sense what's going on in your body, not actually changing what's going on in your body. And in this top slide up here, this shows what happens when you inject a cytokine. You activate the immune system in a mouse, and then you look in its brain about 60 to 90 minutes later. And these little orange areas are the areas that show an increased expression of something called CFOS, which is just a marker of neuronal activity, if you like. And you can see there's a discrete kind of pathway here. It involves this thing called the NTS, the solitary nucleus in the brainstem. And this is the primary projection area for these nerves, and then these nerves then project up to a whole host of other brain regions. So this is fairly comprehensively understood now in mice. And if you cut these nerves, you don't see this, and you don't see many of the symptoms after an infection. And we did a study similar to this, or at least as similar to this as we could do in healthy human beings. And we did MRI scanning, and we took healthy individuals and we gave them a vaccination, something called a typhoid vaccination. And then we scanned them 2 to 3 hours later to see which bits of the brain are more active after typhoid versus when we gave them a placebo injection. And what you see is, again, you see this pattern of areas that light up. And this is, the interesting thing about this pattern is that it describes what's called an interoceptive network. So the network within our body and within our brain that, if you like, understands what's going on to the physiological changes within our body. And we replicated that, and various other groups have replicated that as well. So essentially, it appears that this bit of the body called the insula, or this bit of the brain, sorry, called the insula, seems to hold a representation of the physiological changes in your body, lots of different things, heart rate, blood pressure, oxygen saturations, and probably also inflammation, at least according to our data. There are also other, if you like, humoral pathways. So cytokines can actually get close to the brain. There are bits of the brain, the circumventricular organs, which have a different blood-brain barrier. So the barrier that protects them is a little bit different. And cytokines can act on these regions. And there's some quite nice data. This is data from a mouse again, but this just shows that when you give a mouse interferon alpha and you look in its brain, again, a couple of hours later or 90 minutes later, and you look for a protein called STAT1, which is the protein that responds to interferon alpha. For interferon alpha to have an effect, it has to activate this transcription factor. And you see, within a very short time frame, it's already active in mice. So, and within, again, discrete brain areas that correspond to these areas with altered blood-brain barrier. There are also other ways, and the blood vessels have a wall, and that is also sensitive to inflammation. So when inflammation acts on the wall of these blood vessels, it can cause release of things called prostaglandins, and these can cross into the brain, and they can have an effect, and they can activate these immune cells in the brain that are called microglia. And we can measure them with this type of imaging called TSPO PET. So this imaging technique highlights these immune cells when they become activated. And this is the only study that's currently been done in healthy individuals, but this is only in 4 or 5 individuals. But if you activate the immune system in these healthy individuals, you go from the sort of the yellowy baseline one to the bright red one. I mean, essentially, there's fairly convincing evidence that these cells become quite profoundly activated just by experimentally activating the immune system. And I expect probably many of you will know this paper. This came out of Japan about 4 years ago now, suggesting that these microglial cells, these immune cells, may be overactive in people with ME/CFS. And I say maybe because all of these studies need replication. This was only done in, I forget the numbers, I think it was 8 or 9 people, maybe 10. So it's kind of small numbers. But I think the point here is that, this suggests that even though in the body there doesn't seem to be a lot of inflammation going on 6 months after an infection, if you take somebody with ME/CFS, many of whom will have had an infective episode even many years later, there does seem to be something going on in the brain immune system. So there seems to be a bit of a mismatch. So how can we study this with MRI? I've got another 15 minutes, right? Yeah, okay. So how can we study this with MRI scans then? Well, I'm going to focus on a couple of different areas because these are the areas that we're focusing on within the study. But one of them is looking at subjective fatigue. And inflammation is a very powerful way of inducing subjective fatigue in just about anyone. If I give people even a really mild inflammatory challenge using this typhoid vaccine model, people experience a tiny but significant increase in fatigue. So people just describe feeling a bit washed out and a little bit more tired and a little bit more fatigued. And we've done this study in healthy individuals in 3 different ways. So we've done it with fMRI, which is a way of looking at blood flow changes when a bit of the brain becomes activated, functional MRI. We've done it with this thing called FDG PET, which is a super simple technique. This is just, it looks at uptake of glucose within your brain. So which brain areas start becoming more metabolically active and taking up more glucose. And then this one on the right-hand side is quite a complicated technique called QMT. And this is what's called a microstructural technique. We're not entirely clear what is causing this signal change here at the moment, but I think it's probably a metabolic signal. But nevertheless, we're seeing these changes in healthy individuals after they've been challenged with an inflammatory agent in pretty much the same area. It seems to be this insular area that comes up time and time again, and there are other groups that have shown something similar. So, and this, I want to go one stage further with these data. So first off, this area becomes activated, but does it have any relevance to the symptoms that people are experiencing? And the answer there seems to be yes, it does. So those people that show more insular activation after being inflamed are the ones that experience more fatigue after they've been given this vaccination. And again, this corresponds across the 3 different techniques, 3 completely different group of individuals. So there seems to be something about this insular region that is both sensitive to inflammation and translating that into something that we experience, so a change in behavior and subjective experience. And this slide here just goes into a little bit more detail about what we already know about the insular cortex. And we already know that the insular cortex provides a representation of physiology. So there have been studies done with dynamic exercise. If you get someone to exercise hard, stick them in the scanner, you'll see activation of the insular cortex. If you activate these things called C-fiber touch, so this is like fibers that are involved in pain processing, thermal pain, chronic pain, all of these different things that change the physiology within the body, you see activation of the insular cortex. And that also extends to respiration, graded itch, and all of these other things. So we know that this part of the brain is sensitive to physiology, appears, according to our data, to be sensitive to inflammation, and translating that into subjective experiences. One other area that is of interest is this relationship between inflammation and pain, and by extension, moving from pain, pushing this out to become more abstract, to punishment sensitivity. So we can imagine pain is, if you like, could be construed as one type of punishment, but we could abstract this out more and think about other types of punishment, for example, losing money, which is something that we use in experimental studies. So this is a schematic of bits of the brain that are believed to be involved in the regulation of pain. And this is from Irene Tracy, who I think, has Irene spoken at the one of the Bristol meetings? Well, she's very well known in this field for her work on pain processing. But the important thing, again, to see here is these pinky regions are the insular cortex. So again, this bit of the brain seems to be involved not just in fatigue, but also in pain processing as well, and regulating pain processing. And what we also know from some very elegant work that's been done in Sweden is that when you take healthy individuals and you activate their immune system, you make them more sensitive to certain types of pain. And it's more pressure pain that people are sensitive to rather than cutaneous pain or thermal pain on the skin. It seems to be a deeper sort of visceral pain that they're more sensitive to. And this comes on after a few hours, suggesting that this isn't just hypersensitivity of the nerves, but seems to be a central process that's involved in this. And this is some of our own data abstracting this out to look at, does the system also play a role in abstract types of punishment, so losing money in this case. And again, what we showed in this study is that when you're inflamed, when I experimentally inflame you with a typhoid vaccination, you become more sensitive to punishments. You become more sensitive to losing money. You become less sensitive to rewards, actually, as well. And that seems to be governed, again, by this part of the brain called the insula. So this insular region appears to be having lots of different roles in fatigue, roles in pain, and even more abstract processing of negative information. I think I'm going to skip this little one here because I'm going to run out of time otherwise. But I just want to show you a little bit of data here, just to show that, unfortunately, the world of research is never completely straightforward. And this is a study that we did not using a typhoid model or an LPS model, but this time using patients that are being given interferon alpha for their hepatitis C. And we scanned people before and 4 hours after the first dose of interferon that they were given, and then we followed them up for about 3 to 6 months afterwards. And what you can see on the left-hand side in the green is just that people experience fatigue quite easily after you give them interferon alpha. Within 4 hours, which is the second of these bars, you see a significant increase in fatigue. Some people were quite profoundly affected, other people not affected at all. But as a group, they showed an increase. And that kind of peaked at about 4 weeks. And then when we scanned them using this technique called QMT, which I don't want to talk about too much, but this microstructural technique, what we found is that you don't activate the insula at all. The insula really didn't show very much activity at all, but what you do activate is this region called the basal ganglia. And so the basal ganglia, in the context of interferon alpha, which plays a very critical role in viral infections, activates, it seems to be a different bit of the brain. And we weren't particularly puzzled about this. For the main reason we weren't puzzled is because this is the same region that multiple other groups have shown is responsive to interferon alpha using completely different techniques. So this one's called spectroscopy, looking at the neurochemicals in this region. And what they showed was after interferon alpha, there's a change in neurochemicals within this region that scales with the experience of fatigue. Using this FDG PET, this glucose metabolism, other groups have shown that this also scales with fatigue. And our data also showed that these changes in this striatum region predict how much fatigue people are going to experience 4 weeks later, about 25% of the variance, a quarter of the variance. So if you see acute changes in the striatal region after your first dose of interferon alpha, you're more likely to have more severe fatigue 4 weeks later. And again, these other groups have shown something similar. So finally, let's get on to this little bit then. I mean, how can this help us understand the causes of ME? So this, rather busy slide is a schema of the study. We've got a number of studies running at the moment in ME/CFS, and this one was initially funded by Arthritis Research UK, which is now Versus Arthritis. And then, because there was such an awful lot of work going on here, we approached Action for ME to look to see whether we could get a PhD studentship to take on a chunk of some of this work that's going on through this study. And I'm very pleased to say we were successful in that. And essentially what we're doing is we're recruiting 3 different groups of people, if you like. We're recruiting people with no symptoms of fatigue and no pain, and we're recruiting people who have high symptoms of fatigue, people with high symptoms of pain, and people who have both. And for at the beginning of the study, we thought the people with pain predominant are more likely to have fibromyalgia. And it was interesting hearing from Phil that he thinks that ME is a sort of a spectrum condition. And I'm sort of relatively new to this field, so I was rather sort of agnostic about that position. But we were interested in this because there are some similarities between fibromyalgia and ME, and we thought, can we use these 2 groups of people to try and tease apart which bits of the brain are underlying increases in pain and which underlying increases in fatigue. So we're recruiting these 4 different groups of people. The group in the middle who have pain and fatigue consists of people with diagnosis of ME and diagnosis of fibromyalgia. And we're doing an awful lot of testing. So this bit, phase 1, is a lot of autonomic work. So people are coming in for quite comprehensive assessments, doing tilt table testing, looking at a range of different autonomics. We've got a rheumatologist involved, so he's screening everybody very carefully for any possible rheumatological sort of factors. But I'm not going to focus on that for too long, because what I really want to talk about is what we're doing with the imaging. So in the first stage, people come and do the autonomic testing, then they come back on 2 separate occasions, and they undergo MRI using a number of different measures, so functional MRI, which I've already showed you some data on, this strange technique called QMT, and some other techniques looking at how bits of the brain are physically connected together, called DTI. And what we're doing is we're bringing people in, and then we're randomizing them to give them either a typhoid vaccination on one session or placebo on that session. And then when they come back the next time, we give them the opposite injection. And I can perhaps talk a little bit more about typhoid vaccination. It is the beauty of typhoid vaccination as a tool for studying this, is that it's a rubbish vaccine. It's a terrible vaccine. It doesn't induce immunological memory. It doesn't have any adjuvant associated with it. Only lasts about 3 years, and then you have to use it all over again. So, and one of the beauties of this approach is that there haven't been any cases of people who've been given typhoid vaccination that have ever developed ME/CFS. So we thought this was a good tool to look at a very gentle immune activation in this group. And our prediction is that people with ME/CFS, like all of the data we've shown before, are going to show this bigger immune response to this very subtle challenge, and that they're going to activate these bits of the brain, like the insula, possibly the basal ganglia, we don't quite know which, but I would put my money on the insula, following this challenge compared to healthy control individuals. And this is just a little bit more detail on some of the MRI. I'm not going to go into it in particular, other than to say that the techniques that we're using are all completely cutting edge. They're using something called the Human Connectome Project guidelines, which are the best that there is internationally. And the value of doing that is not just for this study, but it's also for future studies, because once we finish with these data, we'll upload them to a central repository and other people can use them and then add them into larger studies. So I'm just going to show you a few pretty pictures. This isn't data from the study, because we haven't got any data to show you at the moment, because it's only really just started. But these are the sort of pictures that you can get with this technique. So this shows something called myelin maps, if you like, how much white matter there is in the cortex, in the grey matter, essentially, because myelin sort of extends into this. And you can see this helps us sort of look at individual differences in the way that our brains are structured. So you can see sort of the insular blob, the little red one on the top left there. We already know that that is different on the left side and the right side of the brain, and there seems to be quite a bit of variability in the size of that region in different individuals. So one of our hypotheses is that the size of this region is going to differ between people with ME, CFS, and controls, and its connectedness is going to be different, and its reactivity to typhoid vaccination challenge is going to be different. This is just a pretty picture at the moment, but this is the sort of things you can do where you actually look at the connectivity. So which bit of the brain is connected to another bit of the brain? And you do that by following white matter tracks through the brain. And then you can begin to look at, are there connectivity differences between different brain regions in people with ME/CFS or controls? And again, the predictions here relate largely to the insular cortex and the connectivity of the insular cortex. What have I got here? I'm going to jump this because I'm going to run out of time, but there are lots of bits to this study, and one of them involves transcriptomics, or looking at gene expression patterns in the blood. And what we're going to do is we're going to measure all of this, 50,000 transcripts, and then we're going to see if we can find a pattern in here that correlates with what's going on in the brain. So can we link what's going on in the brain with what's going in the body in response to this vaccine? But this is a bit complicated, so I'm going to jump through that. So finally, this is, I think, the last slide. So where are we at then? Where have we got to? So this is our participant testing sessions data. So where have we got to? We're recruiting 100 people for this study, and everyone's going to be tested twice, so that's 200 sessions. And where we're at the moment is where the little arrow is there. So as of today, I think we've done 52 testing sessions. We need to do 200. And, the scientist in me thinks, Beyond this is projections for where we're going to be. But until about a month and a half ago, this is where that line would best fit the data. So this looks a bit worrying to me. We're a good couple of years it's going to take us to recruit everyone. But there's been a step change. Over the last 6 weeks, there's been a little step change. It's gone from laying on this line to suddenly jumping above this line. So this little bit here. So what's gone on there? What's happened to change that? And I think the answer is we have a new PhD student. And Marisa's sitting in the audience. Marisa was funded by Action for ME. And Marisa has hit the ground running. She's only been with us, 6 weeks or so? And already you can see there's a big jump here. And next month she's already got another, I think, 16, 17 people booked in. This is a very demanding study. But I'm very pleased to say that, since we've activated this Action for ME PhD studentship, there's already been an effect within 6 weeks. So I'm very excited that we're going to get this study all completed and all of the data required by September, maybe even November next year. So I'm going to leave things there. There's a lot of people that are involved in this work, but particularly I'm just going to focus on people that are involved with the Action for ME study. So there's somebody called Kevin Davies, who's a very senior rheumatologist, used to be head of medicine in Brighton and Sussex Medical School. Jessica Eccles, Christy Themalis, who's a PhD student, Marisa, who I've already mentioned, and somebody called Colin Smith that some people in the audience may know. He heads the functional genomics lab in Brighton, and he's going to be really critical for helping us with this transcriptomic data and trying to relate that to what's going on in the brain. So I'm going to stop there, and we've got a few minutes for questions, I think. Thank you.
Thank you very much, Neil. We have around kind of 5 or so minutes for questions, and I'm sure he'll be available during the break should you have a question and not have time. I think we have some roving mics as well. So are there any questions? Josh?
Hello. Just to start with, where is this going? What's your end point? What are you hoping to achieve?
Yeah, so at the moment, I mean, what I want. So my hypothesis is that, and listening to what Phil has already told us, that there's heterogeneity in people with ME CFS. My hypothesis is that certainly in those people with an infective prequel to symptoms, that somehow the activation of the immune system has precipitated this disease or this illness. And I think my hunch is that the immune system in the body has probably gone up and then come back down again. It's quite hard to really spot really profound differences in the body. But there's two things that I think are going on. One is, I think whatever's going on in the brain is still going on. So you saw that PET data from Japan. It seems that even though the body immune system seems to be apparently back to normal, clearly it's not, or something's awry, and I think it's in the brain. The other thing that I think is going on is that this immune system in the body probably isn't really normal at all. It's just looking normal, but if you challenge it, what I think is that it's going to be much more aggressive in its response or show a much more profound response to a challenge than people that don't. So these are hunches at the moment. We're doing another study with an exercise challenge to see, because my hunch would be that exercise would do the same thing in people with ME CFS, that lots of different challenges will the immune system is hypersensitive to these type of challenges. And I think, where can we go with this? I mean, if we can show that this is indeed true, then we can start thinking about, well, how can we change this? How can we prevent this? Maybe we need to treat acute infections with people with ME CFS or even people who don't, much more aggressively, much earlier on. There are drugs that can act on these microglia in the brain. We're doing a research study funded by the Wellcome Trust, a big sort of national one, with a new drug that blocks activation of these microglial cells. So there's lots of potential ways for this to run, I would say. They won't be directly part of the project, but I think this will contribute to them.
I think thank you, because I think I can shout loud enough. So one of the things that you mentioned was, I think it was your PET scanning, spectroscopy, and at least 2 of the people who've died and have had ME on their death certificate, at autopsy have been found to have basal root ganglia that are inflamed. So the question is, without having to do an autopsy on somebody, is it possible to screen people generally if they have an ME diagnosis and look at the basal root ganglia? Would that be a diagnostic tool?
Okay, so MRI is a beautiful technique in the sense I can have 1,000 different contrasts that I can look at, even though there's only different combinations of things. We can look at iron deposition, we can look at spectra, we can look at white matter, thickness of axons, all sorts of different things. And I think the basal ganglia are very interesting because they are very sensitive to interferon alpha. So I already showed you that data from our study and other studies, but we know that there are diseases where too much interferon alpha is produced in the brain, okay? And it always affects the basal ganglia. They become calcified. They are very sensitive to this interferon alpha, which is the immediate response to any viral infection. You have a virus, interferon alpha goes up. So I think, and there are ways of being able to map into that. This QMT technique I've already mentioned is sensitive to that. I mean, we've already shown that, but I'm sure there are better ways of doing it. And I think, again, if this study says, look, this is all about the basal ganglia, then we need to start using and bringing all of this armory of different techniques to start really trying to look at that in larger populations. So. There's already one, sorry, I rambled, don't I? So the answer is yes, there is already one technique that we have for looking at this, but there are other techniques as well that I think would be even better. We could use other ones.
Great.
Thank you. Forgive me if this is a rather naive question. I know I don't have a scientific mind. But am I right in thinking that broadly speaking, there are two schools of thought? One, that rest is the answer, and the other, I think you're presenting the notion that activity to stimulate the immune system, exercise, is another way of looking at it. I don't know how polarized these two would be, and perhaps I've got the wrong idea, but that's what I seem to have grasped so far from this morning.
So there's two bits to this. So I think when the immune system in our body is activated, it's not just activated in our body. It communicates with the brain, and it changes brain function, and it changes the immune activity within the brain. Okay, so I think the two are linked, and we've got various other studies we're looking at as that as well. So how does exercise fit in and all of the rest of it? Well, we know that a whole host of different challenges will activate your immune system at some level. So getting up and giving a talk to you this morning, if I measure my cytokines before I got on the stage and now, they will have gone up. Okay? Any stressor will have this effect, and there's massive variability between different people about how this goes on. Some people I've seen with the interferon study, no symptoms at all. Other people completely flat out on the back, unable to do anything. So I think, I'm not sure I can really say too much about, is exercise good, bad, or indifferent on this. But what it is a challenge. And, and that challenge is almost certainly pushing up immune activity. And we have another study funded through the MRC with Mark Edwards in St. George's, looking at exactly at that. We're giving people an exercise challenge, just a standard one, and looking at what goes on to their immune system. And again, the prediction is people with ME/CFS will have a much bigger response.
Any final questions? One over here. Alison?
Is anyone else drawing in the studies that are being done on the gut? Because it seems to be a lot of gut issues, inflammation perhaps going on with ME. Is your study with what's going on in the brain going to link with anyone else's work on what's going on in the gut? Because there's obviously quite a strong connection between...
I've avoided the gut. One of the reasons why I went into psychiatry is because I can avoid really nasty body tissues, like poo, which you have to get if you want to look at gut flora. But no, I mean, I totally take your point. I think, we need to be a bit more joined up in all of this. Already we're collecting a lot of data in these people, so I skipped all the transcriptomics, there's all that autonomic testing. I mean, these are people with ME/CFS. You know, how much can we ask people to do before we have to say, look, this is just ridiculous, we can't ask any more. So we did draw a line with that, and also the funding costs are quite high for doing that. But I totally am with you. I think it would be interesting to look at what is the role of the gut microflora in all of this process. And all I would say is that, all of our data, when we're done with it, will be up in the cloud. People can go and use it or add it to their studies, and I would hope that, other studies that come in will do the same, and maybe this can help inform some of the future studies on gut work, but we're not doing it at the moment.
Okay, great. I'm aware of time and making sure that Alice has enough time to do her presentation, so hopefully Neil can stay in the break, so if you've got any other further questions, then I'm sure he'll be more than happy and willing to do his best to answer them. So thank you very much again.
Good morning, my name's Alice. I've suffered from ME since I was 14. Some of you might be thinking football related. I've always worked in football, so how I'm structuring my presentation is through football. So I forgive me if anybody doesn't follow football, but I'll try and make it as simple as I can, but it's how I describe it best. So let's go. Okay, some of the pictures on the screen, you can see some of my childhood photos. As I say, I've had ME since I was 14. I was a perfectly healthy child, very active, always played sport, keen horse rider, played netball, played cricket. I was the child that wanted to get involved in absolutely everything. I would wake my dad up early on a Sunday morning at 6 o'clock saying, I want to go on a bike ride. So when I fell ill at 14, it was a bit of a shock. I was first diagnosed with glandular fever. So my mum is actually a nurse, so when I was diagnosed with glandular fever, I had a blood test. And for those that don't know, glandular fever blood tests don't really align. So I had a blood test and it came back negative. And it said, you do not have glandular fever, although the GPs in front of me were telling me I did. I was sick for a very long time, and they said that I would probably be poorly for about 6 months. But my sickness symptoms would probably be relieved in probably a couple of weeks' time. That didn't, and I progressively got worse. Okay, so I'm going to mainly talk about my football managers, my assistant and my physio. My two managers are my mum, Sally, and my dad, Martin. My assistant manager is my sister, my only sister called Sophie. And my physio is my paediatrician at the time. He is called Dr. Dilip Nathan, and he is based at the Queen's Medical Centre in Nottingham. So my structure of the presentation is, I'm going to talk through my journey. So starting with number 1, the goalkeeper, the point of no return. So that is going to be the stage of where I first felt poorly. Stage 2 is my defenders. That is my unknown stage. That was the time about 4 months until I got my diagnosis. So until then, I was in hospital with no diagnosis whatsoever. Didn't know whether I was going to survive or not. Stage 3 is my midfielders. Finally, I got my diagnosis of chronic fatigue syndrome. And stage 4 is my centre forwards, forward thinking, so where I am now at age 24. So goalkeepers, my point of no return. A goalkeeper should have good distribution and good communication. Both were absolutely appalling when I first felt poorly. The distribution of help was shocking between my GPs and my family. As I say, I first got diagnosed with glandular fever, and then when I wasn't getting any better, due to my blood count, they first thought I had leukemia. So the testings of leukemia took quite a while. I wasn't reacting to any treatment. They then went on to brain tumours. At this time, I was totally unconscious. I had collapsed in the doctor's surgery. My parents were getting entirely frustrated with the GPs that kept turning me away, saying I had just got glandular fever. At this point, I was totally unresponsive and dropped down to 5 stone in weight. The communication was awful. So at that time, at 14 years of age, I was at high school. That is the time where I was studying for my GCSEs. That was the point where my life should really begin with my career. Sadly, I had to drop out of school for over a year while I was in hospital. But thankfully, that came with the help of Dr. Nathan later on. My unknown stage, this was probably the scariest time between September and Christmas until I got my diagnosis. The defenders should be well organised and controlled. Unfortunately, it was not organised at all. As I say, I had to come out of school for a year, my weight dropped down to 5 stone, and my mum became my full-time carer. My mum had to quit work because of the lack of support I had from doctors, believing that I just had glandular fever and I was going to be okay. Sadly, I wasn't, but my determination made me try and go back to school in that September. I probably lasted 2 days until I collapsed, and I thought, this isn't right. I remember my mum looking at me saying, my daughter has not got glandular fever, you need to do some more tests. And it was just a forever downward spiral. That's when I was admitted to Queen's Medical Centre in Nottingham, and that's where I found Dr. Dilip Nathan. He has been my absolute life saviour. Honestly, he did not really know how to treat chronic fatigue syndrome. He saw me as a bit of a case study, which was quite scary. You go into hospital, you think that you're going to be treated, and you think that you're going to come out of hospital and be made better. I was not. I was sat in front of a highly qualified paediatrician that was supposed to make me better, and he honestly looked at me and said, I am not sure how to treat you. I have never come across chronic fatigue syndrome before this severe. So at the moment, I can only treat you with your symptoms. Those symptoms were severe fatigue, nausea, my concentration was absolutely appalling. I was in an unconscious state for well over a year. Unfortunately, in that year, I contracted swine flu as well because my immune system was so poor and so low. I then contracted swine flu, so then I had to come out of hospital, was treated at home, and doctors had to come and treat me at home just because of how infectious swine flu was at that time. As I say, linking in with the control, there was no knowledge, no awareness whatsoever. So I became Dr. Dilip Nathan's case study at Queen's Medical Centre, and he researched and researched and researched to see how he could make me better. We are still in contact with Dr. Nathan, and I'm forever grateful of his endless hours sat down with my mum and my dad, talking me through what chronic fatigue means, because when you go into hospital, you think you get a diagnosis, you get A, B, and C. You know what medication you're going to take, you know roughly how long you're going to take to make you feel better, and you know sort of a future. You can see a future. I can take this medication and I'll feel better. That is not the case with chronic fatigue syndrome, unfortunately. I was given no medication to make me feel better. I had anti-sickness tablets to try and make me obviously stop feeling sick, and I also had sleeping medication as well, because I don't know if there is any sufferers with ME here, but I was so tired it was as if I could not sleep. And in the evenings, I was like a night owl. He used to call me a night owl because I just couldn't concentrate in the evenings because I just couldn't sleep. And it was strange looking back now when you think you're so tired, you just sleep. But unfortunately, I was so tired, I could not sleep. So my rest and recovery wasn't, as it should be. Next up is my diagnosis. Finally, it took 3 to 4 months for my diagnosis of chronic fatigue syndrome, and that is my midfielders. So a midfielder should be confident, and a midfielder should be resilient. When I got my diagnosis of chronic fatigue syndrome, it was relief in a way, because I'd sat in front of GPs for months and months looking at me as if I was something out of space, something that I wasn't feeling this feeling that I was, and I was making myself feel like that, and I was I was questioning myself all the time and second thinking, am I really feeling like this, or am I making myself feel like this? And I was tormenting myself for months and months. So when a paediatrician sat in front of me and said, right, I've got it, it's chronic fatigue syndrome, ME, it was like a weight had lifted off my shoulders, because I wasn't going mad and I did have an identity, and unfortunately it was a new identity, but it was something that I could manage, and I'm living proof of that. So that is how my diagnosis came about, a bit of relief and a state of mind. Had to change, unfortunately. I had to learn to pace myself, and I had to learn that I couldn't do the things that my friends was doing. 14 years of age, it was difficult. It was when you sort of find your independence, when you first catch the bus on your own or go out for dinner with your friends and your parents pick you up right outside the restaurant or right outside the cinema. And I didn't have any of that right up until I was 16. So I lost a part of my childhood that I will never get back. And obviously that meant dropping down a year. So I lost a lot of my friends, a crucial part in my life, I thought. Resilience. Through that, you have to have resilience when you're diagnosed with ME, just because you feel that there isn't many of us, and you feel that people don't understand how they should understand. Sadly, I started to get better physically a year later, nowhere near as any normal person should feel. But psychologically, I was still in my unconscious state. So it terrified me to go out of my bedroom, out of my house, outside my road, because I hadn't seen it for over a year. So the thought of living again absolutely terrified me. So Dr. Dilip Nathan worked with me through my anxiety and depression because it was quite a scary time. I'm a big Notts County supporter, and that's who I work for. So I remember as clear as day, he used to say the anxiety was the Forest fans, and I had to burn out the Forest fans to make the Notts County fans win. And that is how I battled my anxiety and depression. And he also told me to write everything down. So I became a keen writer when I suffered with ME, because I felt that writing it down meant that I could read it and I knew I could understand. And I felt that not many people could understand other than my close family friends and Dr. Dilip Nathan. I had cognitive behavioural therapy just to help me with my anxiety because of my panic attacks, and I was actually physically sick on myself whenever I got into a situation where I felt unsafe. For those that have ME, it's sort of, whenever I went out, I always thought people knew I had ME. I was the ill one in the room because I was made to feel like that because I'd had to drop down a year. I was the odd one out. People didn't know what was wrong with me. I was the odd one in the corner that had this diagnosis of chronic fatigue syndrome that nobody could understand. So I had cognitive behavioural therapy to help me try and put my life back together, and it did help. And then that's where Action for ME came in. My mum at the front, she became my full-time carer, and she really, really struggled to get any sort of help for me. Whether that was help me get a shower chair, because obviously I couldn't wash myself at all, a stair lift when I moved back home to try and navigate myself around the house, whether that was funding to help me have a tutor at home, because obviously I'd come out of school. There was no help whatsoever until Action for ME came about, and they were incredibly supportive, and they still are, and I'm forever thankful for Sonia, who has come into my life and helped me leaps and bounds. So that is my link with Action for ME, which I'll go on to talk about a little bit later. Finally now, my centre forwards. The centre forward should be clinical and composed. So now moving forwards from being so poorly, I have to move on and try and find a part of me that probably will never forget ME. ME is a part of me and forever will be. I always call it my ME, and I'm extremely proud to have it. And now, obviously, I have to manage myself and I have to be clinical in my decisions, so my job taking. So I was always passionate about football. I managed to go on to university, come out with a first-class degree. I shortened my A-levels, so I didn't do as many A-levels as my friends, and I did it part-time to manage, but then I went to uni, did that, managed to get my degree, and I now have got the dream job. But I have to manage myself even now. So I remember always having to write a diary every week when I was poorly, and I had to write a little challenge to myself every day that I wanted to achieve. That isn't a physical challenge, so that's not me running any marathons. That was maybe walking down the end of the corridor and back, or having a conversation with somebody that I didn't have the day before. Just something that I didn't do the day before to help me feel that I'm making every step in the right direction. But now I can make bigger steps, and that is obviously my job, my family, and my friends. I see my friends a lot. I've made a new group of friends, having to go into a new academic year. I make sure I see them quite a lot. And I call it the new Alice. But the new Alice will always have ME, and I'm not ashamed of that. And whoever I meet in the future, I will proudly talk about ME and my time, because it's a part of me and it's a part of my life that I won't ever forget. And it's something that I always feel that I have to mention. But not negatively, just because if I need a rest break or if my concentration slips, I don't want people to think I'm rude. I want people to try and understand, because people didn't understand for so long. And I feel that when people don't understand, you should try and educate people. It may be not their ignorance at all, but it may be just because they've got no awareness of the illness whatsoever. So why don't we educate them and tell them everything about ME, and maybe then they'll understand. Composed. Try and be composed. I'm probably not composed right now, but I've accepted it, and that was a huge part of having my diagnosis, was actually realising that I had something that I couldn't take a pill to make me feel better and make it all go away. It was something that I'm having to live with and manage over a period of time. So that takes a lot of acceptance and a lot of frustration, actually, because I'm a perfectionist and I work hard at absolutely everything. And now that restricts me with things that I do now. So acceptance was a huge part of having ME. And I have. It took me a long time. But as I say, I'm proud and I'm definitely not ashamed. And I think now everything happens for a reason. It was the worst time of my life. In a way, I can't remember it. I can only remember blowing out my 15th birthday candles. Other than that, I can't remember the year that I was completely unconscious and bedbound. But I see that everything happens for a reason. I've made new friends. It's made me a much better person. It's made me more understanding about life. And it's made me think that life is quite precious, and you have to take everything with a pinch of salt, and maybe sometimes we have to say there's plenty more people worse off than ourselves, but we need to just try and help each other as much as I can. And this is where we've come to now. And as I say, I mentioned earlier, I work for Notts County Football Club, and kindly in Notts County, don't know whether people know about this, but you can have front of shirt sponsors. So in the Premier League, a lot of betting agencies pay a lot of money to have their sponsorship on the front of their shirt. Notts County, we're only in League Two, so we're not in the top flights, but we are a professional football club, and we actually have a different front of shirt on every month to try and raise a little bit more money to help the football club run. And I'm proud to say in September, Action for ME was on the front of Notts County Football Club shirt, which was kindly donated to my dad. My dad is a huge sponsor of Notts County, but he retired last year, and he said, why don't we put a charity on the front? We'll donate the money, we'll create the awareness, and we decided for Action for ME, and we can't think of a better charity for it to have been on the front. So it's been a massive part of my life bringing that into a football, because a lot of the players, a lot of the lads did not know about my illness. Just because sometimes I feel like it's not something that you can just drop into conversation sometimes. But they're educated, they've done an awareness video, and they're really keen to watch it today. They have the day off today because we had a game last night. So I had to travel down from Nottingham first thing this morning, but they're very keen to watch this and learn about the illness and try and help the awareness as much as possible. For those that haven't watched the awareness video that the Notts County players did, please watch it. I know Sonia put it all over their social channels. And that was really to create awareness. So we linked it with football again, and how much how much money, well, how little money is going into the funding of ME. And that worked out to be less than a match day programme per ME patient, which is shocking. So yeah, that's me. And I think the title I've called it is We come as a pair, Emmy and me, and we most definitely will. Has anybody got any questions at all in regards to my diagnosis, symptoms, where I am now? I'm more than happy to answer any questions at all. Thank you. I will be here in the break, but if anybody has any questions later, I'm more than happy to take them.
Thank you so much.